In the world of manufacturing, interfaces play a crucial role. No matter if your company engages in bonding, coating, sealing, painting, printing, and cleaning. In any situation where two materials need to join, ensuring and sustaining the right surface energy throughout the product lifecycle stands as a fundamental key to achieving success in these operations. Process control is critical, and the feedback for this control must be quantitatively sensitive to the composition of a single molecular layer. Surface treatment steps to ensure product performance can include aqueous washing, chemical or solvent cleaning, plasma or flame treatment, laser or abrasion. Process engineers are responsible for overseeing the various production processes within a manufacturing facility while the production teams execute those procedures. Surprisingly, many organizations that work with surfaces and interfaces simply rely on following process protocols and faith to create the proper surface rather than implementing methods to confirm that their process has adequately prepared the material's surface. Within the laboratory, scientists will utilize advanced equipment to assess surface readiness, commonly referred to as surface energy. In the real world of plant floors and supply chains, manufacturers have developed quick methods to validate the surface energy of their materials, even though they may not have known that this is what they are measuring. Over the years, companies all have their own methods to confirm that the preparation process and production have made the materials ready to be bonded together. The most popular one, introduced decades ago, was a chemical test called wetting tension, which uses Dyne inks. With this approach, individuals on the production floor will employ a series of liquids, either in felt-tip pens or in bottles, each containing distinct chemical formulations that elicit a visible reaction on the surface. Despite its inherent destructiveness to the materials, this method gained widespread popularity due to its ease of use and its low cost. However, issues arise due to damage it causes to a part and the inconsistencies in data due to operator variation. There are also very real concerns regarding potential employee exposure to the harmful chemicals used in the Dyne inks. Over the last decade, a new technique for measuring surface energy in production environments has emerged, and many of the world's best manufacturers are moving to it. Water contact angle provides the portability and ease of use as Dyne inks, but has none of the disadvantages. We'll discuss more about how Brighton Science leverages water contact angle measurements as a fast, easy, accurate, and highly repeatable testing method to evaluate the surface energy of various materials. Water contact angle quantifies the angle formed when a water droplet comes into contact with a surface. This method relies on the fundamental principle that a material's surface energy dictates the behavior of the droplet. Using the surface analyst, a water drop is deposited precisely onto the surface in question. Through high-resolution imaging and image analysis software, the tool quickly and accurately measures the contact angle of the water drop on the surface. The shape of this one tiny droplet provides a wealth of insight into the surface's cleanliness and wettability properties, along with its ability to form a strong bond with a paint, adhesive, or ink. Now, let's look at how Dyne solutions compare to the immediacy of the surface analyst. Dyne solution measurements, commonly used to assess surface cleanliness and treatment level, also hinge on the principle of wetting, looking for the one solution formulation that spreads uniformly across the surface. Nonetheless, this approach has inherent drawbacks. Variables like operator skill in interpreting the behavior, the presence of soluble contaminants on the surface, as well as factors like the age of the solution or the condition of the applicator can significantly impact the outcome, making it difficult for the user to accurately interpret the results. Relying on visual evaluation of wetting patterns is subjective and prone to human error, making it challenging to obtain consistent measurements. Another significant drawback of Dyne inks is their potential to damage the parts you're evaluating. The test fluids used in the inks will dissolve and mask any potential contaminants present on the surface, which ultimately creates inconsistencies in your findings and risks the integrity of the part you're measuring. In contrast, water contact angle measurements offer several key advantages to unlocking surface intelligence. And by leveraging the advanced imaging technology in the Surface Analyst, this allows for fast and accurate contact angle measurements of the surface, reducing human error. Water contact angle measurements are fast and repeatable, enabling consistent results across different operators and environmental conditions, allowing for efficient analysis of large sample sets and time-sensitive experiments. This reliability makes it a preferred method for quality control and research applications. Because water contact angle utilizes HPLC-grade water, it's ultimately non-destructive to the surface you're measuring on, reducing scrap along the way. The power of a single water drop unlocks new opportunities through the acquired data, allowing manufacturers to track, trend, and trace all measurements and to control the quality of their parts. In conclusion, while traditional methods like Dyne solutions have their limitations, water contact angle measurements offer a fast, repeatable, and highly accurate approach for obtaining precise data when it comes to the surface energy of your materials. This user-friendly solution has the benefits of being quick, easy, non-destructive, and appropriate for many types of processes. Brighton's Surface Analyst family is built on a powerful system that provides the surface energy data you need in the format that unlocks the value of surface intelligence.